Hello everyone, so welcome to my channel. So in this video I will show you how to do what. Well, I found this question underlying simultaneous equation and region. So we're going to look at this example of finding the equation of the line perpendicular to a certain line. So before we begin, I want to let you know that the equation of a line has a general formula, which is the one that I've just written here, which is y is equal to mx plus c. I remember doing the video on the same equation of the line where we said this is simply the common difference among the y-axis, or which is the range, and then c stands for the constant. Well, of course, we have, of course, it is m is for the common difference in the y-axis. But during this video, we're going to use the special name which we give to m, and that is called a gradient. And of course, c is the y-intercept as indicated by this sentence there. So now, how do we find the gradient or the equation of the line perpendicular to another line? Well, when two lines are perpendicular to each other, they have something in common, and what is common is that their gradient is the opposite of the other, or is the opposite reciprocal of the other, so to speak. What do I mean by saying opposite reciprocal? Because it looks like I'm just saying one and the same thing. Well, if I just say reciprocal, it means that I'll talk about maybe flipping them, some sort of. But now on this one, even the sign is also affected. For example, if the gradient is 2, the gradient of the line perpendicular to the one which has a gradient of 2 will be negative 1 over 2. So now let us get to business and find now the equation of the line which is perpendicular to this line there. So I'll call this as my solution. Yeah, so don't get tired. We're going to go step by step. But first of all, we don't know first of all the gradient here. Why? Because it should be in the format of this. So what does it mean? It means that on this one we have to make y the subject of the formula. And how do we do that? We're going to, let me just rewrite the same equation by saying 5x minus 2y, okay, minus 11 is equal to 0. So now in making this one the subject of the formula, of course we know that this can also be expressed as 5x minus 2y is equal to 11, not so. Yeah, that's because we just moved this 11 to the other side and then it became positive there. So we're going to use this same one and then make the y the subject of the formula there. So we'll start from here. We're going to say negative 2y is equal to, allow me, of course I've taught in many of my videos taught that the number that crosses the equal sign should be in front. So for the sake of the gradient where m is just after the equal sign there, allow me to put negative 5 just right here and then plus 11 to just adjust a bit. So I have negative 5x, this one here, plus 11. Then from there now I can divide both sides by negative 2, even here by negative 2, so that this one and this one cancels. So we have y is equal to negative 5 plus 11 over negative 2. Now notice that on this part we can still separate these by saying this is same as y is equal to negative 5 over negative 2 plus 11 over negative 2. And again, if we divide here, it will just be y is equal to oh, there's x here, so y is equal to 5 over 2x plus 11 over negative 2, just like that. So now we have made y the subject of the formula, And when we make y the substitute to the formula, it means that this equation that you are seeing here is just the same as this one that we've just formed there. And you know that we say that m is for the gradient, isn't it? So m is represented by 5 over 2 there. So it means that the gradient of the line perpendicular to this one will be the opposite reciprocal. It means that it will be negative 2 over 5. So already now in answering the question where we said y is equal to mx plus c, now we want the line, the equation of the line. So we have the gradient already, which is this one for the line. Now the one perpendicular to this line is going to be the opposite of this, the opposite reciprocal of this one. So that one is going to be, so m is equal to negative 2 over 5, isn't it? So let us go ahead and plug it in here. So we have y is equal to negative 2 over 5 plus c. So there's another detail that we're given in the equation. They are saying that this same equation of the line, it is passing through the point 2 and negative 3. So the value for x is 2 and the value for y is negative 3. So let us go ahead and substitute these values in this equation there. So where there is y, we're going to put negative 3 is equal to, here there should be, I don't know why I'm forgetting x, so here there's x there, negative 2 over, that is 5. Then where there's x, we're going to put what? We're going to put 2 there, 2, then plus c. Remember, the reason why we're doing all of this is because we want to find the value for c. All right, okay, so I have negative 3 there is equal to, this one will be negative 4, right, over 5 plus c there. We're good? Okay, so if I'm too fast, you feel free to pause the video, process the information, and even just keep on rewinding, and then you're going to get the sense from this video. All right, so from there, what do we do next? We're going to move this one to the other side, isn't it? So we're going to have negative 3 there, then this one will be positive, plus 4 over 5 is equal to c. So let me just put this one as over 1, then the common denominator here, it's 5. 1 into 5, it's 5. 5 times negative 3, it's negative 15. 5 into 5, it's 1. 1 times 4, that is positive 4. Right? So I'm just for, okay, let me just is equal to c. So here we're going to get what? Negative 15 plus 4, it's negative 11 over 5 is equal to c. So it means that our gradient on this one, our gradient is not our gradient, rather our value for c is c is equal to negative 11 over 5. All right, so let us go ahead and write our general equation for the equation of the line, where we say that the general equation is y is equal to mx plus c. So y is equal to, y is equal to mx plus c. Did we find m? Well, we had found our m to be negative 2 over 5. So y is equal to negative 2 over 5, that is x, right, plus our c is this one we just found, which is negative 11 over 5. So plus negative, so it will be just minus 11 over 5, and that becomes the equation of the line perpendicular to this line. So first of all, you have to make y the subject of the formula. That is if it is not the subject, because sometimes they may give you y as already the subject of the formula, and then everything is perfect. You just get the one which is with x as your gradient there. And remember that the gradient of the line opposite to perpendicular to a certain line is the opposite reciprocal. It means that if it was just a whole number, like a single number, then you just say -1 over that number. And if it was a fraction, you just flip them, and then you have to get the negative there. So just like what we did here, we found that after making y the subject of the formula, we had y is equals to 5 over 2x plus 11 over -2. And then from there in fact this one should be negative 11 over 2, right? Yeah, it should be negative 11 over 2, not like this one. But anyway, our main interest is on this one, because this one is already positive. So since it is positive, when we want the gradient of the line perpendicular to this one, we just flip these and of course give them a negative sign. After that, we substituted it in the general equation there. From the general equation, after putting it here, we wanted to find the y-intercept. And how do we do that? We've been given the points where this line is passing, that is 2, -3. Then we just went ahead and plugged them in to find the value for c, and that's how we found the value for c. And our final answer is, we say that the equation of the line perpendicular to 5x minus 2y minus 11 equal to 0 is y is equal to -2 over 5x minus 11 over 5. So I hope you liked this video, and if it's the first time that you're watching this video, please subscribe to my channel, and your comments are also appreciated. Thank you.